if the instrumental variable z is relevant and exogenous. Relevant means that the correlation between x and z is non-zero, and the exogenous part is that the correlation between z and the error term is 0. And if we are lucky enough to find this instrumental variable, then we can estimate the true beta using the two-stage least squares method. And this is just a two-stage regression analysis. Let's say you have data on the y variable and the x variable, and you have gathered data on the instrumental variable. And now, instead of regressing y on x, you actually regress x on z, which means that you use the information in the instrumental variable to explain the variation in the x variable. And remember that this instrumental variable, it's not correlated with the error term, which means that it's exogenous. It's not affected by the error term like the x variable is. So when you estimate this regression, you actually get the estimated estimated x variable given information in the z variable. And in the next step, you can use this fitted value in a different regression. So now you have the fitted values, and the correlation between the fitted values and the error term is actually 0. Because as you saw in the in the last step, this v contains the part of x which actually is correlated with the u, the error term. So if we regress the y variable on x hat, then you get the two-stage least squares estimators, the intercept and the slope, and the slope is the parameter of interest, because this is the causal effect of x on y, which is exactly what we are looking for. And as you get more data, then this beta, it's equal to the covariance, the sample covariance between y and x hat, the fitted x value, divided by the sample variance of x hat. How do we know whether or not our instrumental variable is relevant and exogenous? Well, the first part, the relevance, can actually be found quite easily. So here, you know that you have the regression x equals pi naught, which is the intercept, plus pi 1, which is the slope, times z, plus an error term v. So the error term, it contains the part of x which is correlated with the population regression error term, the u. So what you get is an estimate of x plus an estimate of the intercept plus an estimate of the slope times the z. And this x hat, it's not correlated with the population error term, the u. And here, with this regression result, you can look at the f-stat to check whether or not this slope is actually equal to 0 or not. So if you get a large f-stat, then you reject the null hypothesis of no relevance. And the reason why you can look at the f-stat is that for bigger models, you might have more than one instrumental variable, and you then perform a joint test of relevance. We look at the value of the f-stat to decide whether or not we have a strong instrument or if we have a weak instrument. If the f-stat is greater than 10, we say that we have a strong instrument, and if it's less than 10, then we have a weak instrument. So if we have a strong instrument, then we can use that instrument, that variable, that z variable, to explain a lot of the variation in the x variable. And in case we have a weak instrument, our z variable does not explain a lot of the variation in the x variable. And then the two-stage least squares no longer gives us reliable estimates. And just be aware that if you have a single instrumental variable, then you can look at the t-stat, and if the t-stat is around 3.16, then the f-stat is around 10. Why would this weak instrument be a problem? Well, let's consider a no correlation between z and x. Then, from the equation of the estimate of the beta above, we see that it was the covariance between z and y divided by the sample covariance between z and x. And if the correlation between z and x is 0, then the covariance, the sample covariance between z and x equals 0. And then you have an exploding estimate of the true effect of x on y. So that's the case for relevance. What about exogeneity of the instrumental variable? The problem is that u, the error term, is unobserved. So what we need to do is that we need to use economic theory or expert knowledge to decide whether or not there should be a correlation between the variable that we have chosen as our instrumental variable and the error term. And the problem is that the error term contains absolutely all the variables which have an effect on our y variable, but is not included in our model. So we need to really think hard and long on this problem, and one thing we can do is to perform something called a J-test, but this can only be done when we have more instrumental variables than endogenous variables. So if we have more z variables than x variables, which are correlated with the error term, then we can perform something called a J-test to get some knowledge of the exogeneity conditions.